So, all right, let me get going. Welcome, everyone. And today what I wanted to do was get going with the visual questions that we have today. Folks will continue joining as time progresses, so we'll get them reeled in as appropriate. So the question that I have, the first question I have here is a geometry question again. If you're given a bunch of points, x, y coordinates, here's a sample set on the website. The goal is to find out the most number of collinear points. And how would you go about doing that? Any suggestions?
May I volunteer?
Yeah, go ahead. I'm going to let you.
Okay. What I would do is I would start off, just grab 2 points from the set of all points, calculate the slope between them, and then add them to the new set, because any 2 points will establish a line, and you've got the slope. Then you keep going through the other points in the set, and take and establish the slope between them and point 1, and if the slope is the same, then they will be collinear, and you can add them to that set.
I want to challenge you there. Are you telling me that if there are two sets of points that have the same slope, are you telling me that they're collinear?
Only if they're all calculated with the same beginning point. So, for example, if you take point 1, for example, and you establish that point 2 and point 1 have a certain slope, okay? You've established a line between those two. If you grab point 3 and calculate its slope with point 1, if the slope is the same, it's got to be collinear because it's with point 1. Now you can have. So you see what I mean? So you can have lines with the same slope that aren't collinear because they have different y-intercepts, different x-intercepts, But starting from that one point and establishing a slope with the others, because you've anchored them to that one point, then you know.
Okay.
And then what I would do is for the next set, so basically I've got my original set of all points, and then I've got a set of points that are collinear with points 1 and 2, right? Mm-hmm. For any points that weren't in that second set, I would again take point 1 and at that point establish a slope and then go through the set that wasn't collinear with the first set. So all of the ones that were left out of set 1, until you have no points that are not in a collinear set. And then, of course, the largest set would be the one, as I said. And yes, I agree with you that having the same slope does not make them collinear, but if you have the same slope with the same point, then it's got to be.
Yep, okay. Makes sense.
But
go ahead, Geek.
Yeah. But if we exclude any points that we have already visited into the previous lines, right? We may be in a situation where a point could have been in another line where it could have participated and make the other line bigger, but it does not. Like, for example, if you see the red line and the blue line, if you pick the first red dot, which is the leftmost red dot, the topmost and the leftmost, and then you start looking for other dots, and you get the second dot in blue, and you draw a single line with that. That is just 2 points.
Yeah, by collinear, I was thinking of the classic geometry definition where the line is infinite length, has no endpoints.
Yeah, but how would that change it? For example, if you get the point which is the leftmost and the topmost right point, the point on the red line, and the next point that you get is the second point on the blue one, right? And then you will not be able to find any other points on the same line, so you will think that these are the same points. You will exclude the blue point into another one.
Yeah, and as I said, yeah, go ahead.
I didn't get your point because we will be storing all the points that we have visited, and we will also, so for example, if we are taking the top blue point, right, then if that is the first point that we are considering, we'll go through all the points and we'll see if there is a slope, and then if there is a slope, we will store the value of slope or somewhere, or maybe the starting point somewhere, and then for every point we'll do that. So it will be order of n square solution, right? So I mean, I don't get like by your point that what are we excluding?
Okay, if you have a point, you establish your line with 2 points and calculate the slope.
Mm-hmm.
And then using one of those points and calculating the slope with another, if the slope is the same, then they've got to be collinear.
Mm-hmm. Yeah.
Because you're anchoring them to points already established in that line.
Mm-hmm. Okay. Yeah, so I'm sorry, I don't know the name of the guy who was speaking. So I agree with your point that we establish slope with 2 points, and then we'll see the other point, and we'll see, okay, it has the same slope with the starting point. Then we, okay, say there are 3 points with the slope with this particular starting point.
You don't need the same slope, right? You just need you just need to satisfy the line equation.
Okay. Yeah, I think you need to have 2 factors. One is the slope. The other one is when x equal to 0, the y value. And also you need you need to consider.
You're talking about the y-intercept, but I was getting around that by using one of my already established points as the point to calculate the slope with, which took care of that problem. Because I know it's y equals x plus b is an equation that establishes a line.
Yeah, I think you need both b and slope. So the b and slope determine if they are on a line. And also there are some special case such as the slope. Let me see. If it's a parallel line, you have to the slope is okay. If it's a vertical, then you need to consider it vertical. If it's vertical, you need to compare the x value. So I would say maybe to create a map, and then the key will be the equation, the slope and the factor.
Well, that's why I compared. That's why I compared other points to the first one, because that first one kind of anchors the intercept.
Mm-hmm. Yeah, I think you probably need to go through loops, two
yeah,
comparing every other point, find out the slope and the b value, and if the slope and b value same, you put in a set, and then in the end, which set has the largest size?
So this will be n cube, right? This approach will be n cube, right? Because you have set of 2 points, and then for every selection of 2 points, you will have to go through every other point, n minus 2 points,
yes,
to figure out whether they have the same slope, right?
So this is n squared.
But you do already.
N square. Yes, it's n square.
Yeah, you pick the first point, and then if the second point, it is always in the same line as the first point, and then you do it from the third point onwards, and then see if any other points are there, and then you loop it down for each and every point.
Yeah.
It's n cube, right?
Yeah,
or
but
we can do n square.
Well, why is it n cube, Gaurav?
Yeah.
Gaurav, can you explain why is it n cube?
So because you're selecting 2 points, right, to make the first intercept. So like there are n square choices for that, and then given the 2 points, you loop through the rest of the n minus 2 points.
I see. So
right?
Yeah. So you definitely can eliminate some of the iterations just looking at the. So
if you use a map,
yeah,
right?
for instance,
if you use a slope map, like a map with, let's say you calculate the slope of.
No.
Alternatively, right? I'm just thinking out loud here. Alternatively, right? If you just put a hash map with the key as the slope, and then the points which have the same slope are added into that hash bucket.
Well, as I said,
they're not necessarily.
Okay.
in one line, even the slope same.
Yeah, parallel lines
Yeah.
have the same slope.
You need a point and a slope to establish
Yes.
collinearity, or a y-intercept and a slope to establish the collinearity. And that's why I used a point, because a point with a slope, because that gives you, it infers the y-intercept.
Yeah, I agree with your approach. I think it works, but I'm just saying that's n cube, and maybe we can, by maybe using some extra memory or something.
I don't think it's as bad, because once you've used up points, when you calculate a new slope against another point in that previous set, you know the ones that fit together won't work there.
Yes,
So I
agree,
don't think
but,
it's
like,
n cube.
I think it's n cube, right? I mean, I might be wrong in the analysis, but
Gaurav, let's take a step back, right? So if you were to select 2 points from given all the points, in how many ways can you select 2 points?
NC2, right? So
NC2 is n square. It's an n square thing. It's actually n times n minus 1 by 2, right?
right.
Okay, so that is an n square approach. So with n square calculation, you can calculate all the slope plus c combination, correct?
Correct. Yes.
Right.
So instead of, you shouldn't be storing a point along with this. You should actually be storing a pair of points along with the slope and constant.
Right.
Right.
Okay, so when you do that,
Okay.
right, so you've stored points. So point A and B will be in the first slope bucket, and point A and C will be the second slope bucket, and so on, right?
Yes. Yes.
Correct. Now, what you will actually see is that it is possible that point AP, AQ, AX, they're all like collinear. That also means that PQ, PX, and QX will also be the same X bucket.
Yes. Actually, yeah, that's correct. Actually, so you have a list of points for every slope comma intercept pair in a dictionary. So whichever dictionary is the highest length. I mean, the value of whichever dictionary has the highest length. That is the line that you have to return. That's all.
Okay. So that will work.
That will work.
And that's
yeah.
an interesting approach. So the other approach I have seen people take is also to collinearity is established by 3 points, not 2.
Mm-hmm.
Okay. So if I take sets of 3 points, you can actually tell me whether they are collinear or not. Right? So once you have a set of collinear points, go ahead. Sorry, Emily, was that you?
So that would make it n cube, right?
Yes. Because how would you select 3 points? That's actually NC3, right?
Yeah.
Yes, it will be an n-cube solution, but that's another approach that I've seen people commonly take because we say collinear, right? So what they'll do is that they'll take all the collinear points and they'll take points in sets of 3, detect collinearity, and then after they have detected collinear points, they will see if you have A, B, and X are collinear and A, B, and Y are collinear, then that automatically means that A, B, X, Y all are collinear. So they have to do a post process after that to get there. So these are 2 different approaches. Clearly the pairs of points with the M and C as the key for your hash map or the dictionary makes the most sense. Right?
Yeah, agreed.
Right,
hi,
so,
Vivek,
yes,
I'm kind of summarizing. So based on my understanding, I was thinking we have to find the slope from one point to every other point, and by using y2 minus y1 by x2 minus x1, and then whichever pairs has the same matching slope, they are collinear, right? That's what
so
the
slope,
first.
it's not just slope. You have to also do slope and y-intercept. It's y equal to mx.
Slope and y-intercept or slope and a point will establish that.
We can't do slope and a point always in this case. It'll be super hard to get that.
Right.
True.
Yeah, and like one of the members mentioned, slope can sometimes be infinity. You have a divide by 0 errors on vertical lines. So you would have to see how you would represent that slope in the representation you're using in your dictionary.
That is a great call out, Arun. Yes. You will have a scenario where the slope could be infinity if it's a vertical line. If the points are in the same x but different y's, the slope is infinity.
So I had
So you can represent that as a rational number where it has two parts to the number. So your dictionary can be a component by that, a tuple kind of thing. So yeah.
So I had a question. So in terms of storage, right? What we need is it a hash map or just like a double array of like n square where we are storing like a tuple of slope and intercept?
No, you need to somehow collate them all. So you need a hash map.
Wouldn't like a doubly, array would do, like where I have the points, like it's a matrix, right? So
yeah, but like your lookup will become more. So when you want to look up the slope,
so it's a square, right? It's basically a square where the row is like every point, and then the column is also every point. And then it's a constant lookup, right? I can just look up the points by the index.
Yeah, so that will depend on the size of the the axis you have. Like if your first point starts at 1 million, you would have to allocate 1 million length of metric.
Yeah, I mean it's totally the number of points, right? I have all the points at my column, right? And then every index I'm storing like a tuple of x intercept and slope.
I'm not sure I understand what you said.
I'm not following. Can you restate that? Is that Karthik?
So it's basically it's a matrix, right? Where I have like the rows have like each of my points, and the columns also has like each of my points, and then I'm calculating basically the slope and the intercept of one point with the rest of the others.
See, that makes sense, but how will you collate the information? As in, how will you identify the pairs of points that have the same slope and same constant?
I see. Oh, okay. Oh, so there
somehow you'll have to do that.
Like, okay, I get it.
Okay. Then otherwise what you'll do is you'll end up going through another n square pass across the entire thing to figure out, but then it's not just n square. You have to keep repeatedly doing it to figure out what is the most one. So again, essentially you will have to put it in some kind of a hash-like structure.
I see. Okay.
So if you are using a hash map, what will be the key for that?
The key will be a composite key, which actually will include m, the slope, and c, the constant.
Okay.
And you may actually, if the slope is infinity, we'll just use a way of actually notating that.
Okay.
But I have like the other thing that I was thinking, right? Like, so if we have like all these entries lined up in a matrix, right? So then basically wherever like I have the same entries, I am basically, as I'm constructing it, I'm keeping like a count of it, right?
So who's speaking?
Whether it's it's Kontea.
Okay, all right, go ahead.
So I'm keeping a count of like whether it has already occurred or not, so that's hard to figure out, I see.
Yeah. All right, so from a solution standpoint, I think Kavita summarized it. We'll have to do a n square pass, essentially taking all pairs of combination between point A and point B, like take all combinations, and then once you're done with that, you'll be collating the M and C. In this case, the one thing to actually figure out is that it's a terrible idea to have a floating point number as a key in a hash map. Why?
Because it's a bit imprecise.
Yes. What does that mean?
The precision varies for storing floating points.
So what does it mean?
So basically, you cannot do an equality on floating point will fail. So I guess the internal implementation will be flawed because of that.
Correct. So I don't know if folks got that, but it's a very specific question here, because the thing is that The problem with floating point numbers is that it's actually the decimal representation in terms of floating point, right? A 1.0 floating point is not necessarily 1.0. It could be 0.999999, or it could be 1.00001, or it could be anything. There's an error there, and in theory, the floating point equality is never guaranteed. So a floating point number 1.0 is not the same as floating point number 1.0, typically. And you should be using less than or greater than comparisons when you're doing floating point comparisons. Or if you're trying to compare equality, what you need to do is you need to do subtraction between A and B and making sure that the delta value between A and B is less than what's called epsilon in this case, which is like a permissible difference between the two. So there are two floating point numbers are never equal, they're just close. So when you do a hash map kind of an implementation, the key being of not just one floating point, but we have two floating point numbers. Both M and C are floating points, so that's fantastic.
Yeah.
So I think the goal here is for folks to realize what's the problem with floating point. If you do not know how floating point numbers are stored, the characteristic and the mantissa, I suggest you like either wiki it up or go open your computer science textbooks to just see how that is actually stored and how they are imprecise, and you cannot do comparisons as such.
Right.
I did not understand the question. So there was a question from Raj which is saying we have to calculate y-intercept with respect to which point. Like each pair of points define a line, and you have to calculate the y-intercept for the line. And the y-intercept for the line actually essentially means that it is the point at which the line intersects the y-axis, which is at x equals 0. What is the location? So you need to store that constant, and you need to store the slope m, right? So just a quick anecdote here is that in one of the examples that we've had in programming life is that we have this concept of we show customer a price, and then we just let the customer buy. When you just click on the button to say, yep, I want to buy it, we just automatically charge the credit card and we purchase. Unfortunately, the problem is that we charge not the price that we show, but we charge the price that it currently is. In most cases, it's the same. Like, if you look at a page, it says it's $3. You hit buy, the price is still going to be $3. Unfortunately, if you've had the page open for too long, or if the price has been updating or something, there is a possibility that the price is a little different. So the wise folks actually implemented a logic that said that they actually pass on the price that they showed to the customer to the next step, and there they would compare, saying that if the price is less than the price that we showed them, then we will let the purchase go through because they wanted to buy it at $3 and now the book is $2, and then we will show them like hey, congratulations, you saved $1 or something like the book was only $2. Or the other way around is like saying like, oops, the price went up to $4, do you still want to buy it? So this was the message that we were showing, and everything was fantastic except that a bunch of customers are getting a message saying, congratulations, you saved $0, and oops, the price went up by $0. Still want to buy it? And guess why?
It was floating point, not decimal.
Exactly. So the problem was that the system was using floating point for comparison, and the price that the customer came in is different from the price that they're seeing because $3 is not equal to $3. And we were not doing epsilon comparison, so sometimes we would actually do $3 is greater than $3 in certain scenarios.
I remember
less.
So I have kind of a language question. In this example, we are storing like a tuple of a slope and intercept, or say a list of a set of slope and intercept in the hash map. So is it going to hash it based on the contents of the list or set, or is it based on the object ID or the reference number in the JVM? I'm not sure.
That's a brilliant question. If it is based on the object ID, then no two object IDs will be the same.
Yeah, so it's not a problem then.
It cannot be. It cannot be based on object ID. It has to be based on the implementation of the equals method and the hash code method.
Oh, I see.
Yeah.
Right? Back to fundamentals. How does a hash map work?
Right.
All right.
Yeah, you're right.
Enough of
I
this
know one
question.
thing.
Go ahead, Pamela.
Yeah. We had a database problem with billing, and we had to use the database's round function constantly to end significant digits, and sometimes it wouldn't add up, but we always just use round, you know.
And it won't work.
And we were
That's
dealing
why.
with. Well, sometimes we dropped a cent, but it's what we had to do because we were dealing with hundredths of a cent. So, ugh.
No. But here's what it is, right? If you had 50 cents, all right, when you round it to a nearest dollar for simplicity's sake, what do you expect it to be?
Well, it's going to be $1, but I'm just saying we rounded to 4 significant digits. So
No,
we were dealing in fractions.
It is not always $1. It is not always $1.
Yeah.
50 cents, when you round it, and if the internal floating point representation is actually 0.499999, you round it, it actually becomes 0. 50 cents when rounded is actually non-deterministic in floating point. Anyway, so moving on to the next question, is there anyone who actually needs a little bit more insight or information about the first question?
Hello, this is Sirika.
Go ahead. Yes, go ahead. I thought I heard somebody speak. Go ahead. All right. If you find your voice, please shout out again. All right. Moving on to question 2. So, given a bunch of points, very similar to the previous question, the goal is to actually identify the number of unique triangles that you can form using these points. It will be very simple based on what we just discussed. So go on.
Yeah. So if 3 points are not collinear, they can form a triangle.
Okay. So how will you actually identify the number of triangles you can make?
I think we can just put a count, and then while we are looping and checking if it's collinear or not, and we can just put a count and keep adding the counts. So we'll get the different number of triangles that we can make.
And what is the time complexity of that algorithm?
I think it's going to be the same order of n square, because
No, it will be n cube if you do collinearity with 3 points.
Yeah, but yeah. So
what you need to do actually for a smarter solution is possibly to do a collinearity with n square, which is the algorithm that we just discussed for question number 1. And then you would have created sets of collinear points.
Yeah.
Right? And now your goal is actually to pick 3 points from all of these sets in such a way that you don't pick from the same bucket thrice. And there's like a mathematical way of actually figuring out how many ways this can be done without actually having to enumerate all the cases.
Basically, NC3 minus the number of collinear points.
You don't have to enumerate all the triangles. You just have to tell me how many triangles you can make. The goal is to return a number, not to return the total, not to return all of it.
Basically, NC3 will be n into n minus 1 into n minus 2 divided by 3, right? And then
got it. I see it.
Minus the number of points you already calculated in step 1.
Got it. I misunderstood what you said. Yeah, that's right. So the number of ways you can actually select 3 points is NC3 out of n, and then of which you know all the invalid combinations, because using an n square algorithm that we just discussed, what you have done is you've actually figured out which of the triangles are not viable, and then you can just subtract those based on those sets. Yeah, good point. Yeah, that's kind of what I was alluding to.
So it's NC3 minus length of set 1 C3 minus length of set 1 C3 and set 2 C3 and so on, right?
That is correct.
Okay.
That is correct. there anyone who has a question on that? I'm just skipping question 2 and keeping it brief, but does that make sense? Is there anyone who needs more explanation on question 2?
I just want the summary again because I didn't understand it.
Sure. So what is the number of ways you can select 3 points from n points to try to make a triangle? It's n choose 3, right?
Yeah.
So that's NC3. So that's the total number of ways you can do that. Using algorithm 1, you have figured out sets of collinear points, right? And these sets of collinear points are actually just sets of collinear points. And what you're trying to do is, if you look at the first set, let's say it has 20 elements, then there are 20 C3 triangles that are possible, or like combinations that you can select, which essentially will be unviable triangles from the first set, correct?
Okay.
And the second set, let's say it has 30 points, 30 C3 are unviable triangles from the second set, and so on. So every collinear set, you just do a C3 of the length of those sets, and you can just subtract them from the master number that you have to figure out the number of viable triangles you can make.
Okay, gotcha.
Well, pretty easy actually. It's a mathematical question, not a programming question, but it's just thrown in there as a follow-up of the previous question. Right?
I have one doubt. Hello?
Yeah, go ahead.
Yeah, so why are we subtracting the length from the set of points we have got?
We're not subtracting the length. What we're actually subtracting is the let me take it as an example, right? Let's say you have 100 points. Okay. How many ways can you actually choose 3 points out of 100 points? That will be 100 C3.
100 C3, yeah.
Correct. Now you have determined collinearity. So you have determined collinear set 1, collinear set 2, collinear set 3, and so on. And say collinear set 1 has 5 points. Which means that if you take 5C3, that will form the ways in which you can select 3 elements out of set 1?
Yes.
And none of those 5 C3s can actually make a triangle? So you have to subtract that from the 100 C3, right?
Yes, yeah, got it.
Okay, and then you have set 2, you have set 3, you have set 4.
Yes.
So essentially, if set 1 was size S1, set 2 was size S2, set 3 was size S3, then you essentially have to do S1 C3, S2 C3, S3 C3. These are all unviable combinations.
Yes.
Does that make sense?
Yeah, that's
awesome. Who's speaking, by the way?
Shweta.
All right. Fantastic. So.
Okay. Thank you.
So moving on to the next one is that number 3 is that you're given a circle with radius r and center at x comma y. In the example that I've given here, the center is in 0 comma 0, but you can easily translate it anywhere. X, y, and r, all the 3 are integers. I want you to list out all the points P and Q that lie inside the circle where P and Q both are integers. How would you go about solving this? I just would like to give an opportunity to someone who hasn't spoken yet.
Okay, I'll shut up.
All right. Anybody with a solution?
Well, I can't think of anything off the bat, but maybe if you did something with, give it a circle with radius.
Who's speaking?
Does my speaking count when I spoke about the first question?
Hang in there 1 second. Let's give a few other folks a chance.
Yeah, and this is Kavita. I was thinking maybe from the center, we can calculate the diagonal distance for the xy points. So since it's a right angle triangle, if you assume a right angle triangle, if radius, what is the diagonal distance of the xy point from the center is less than radius, then they are inside the circle.
That is correct. how will you find it out? How will you? So would you just enumerate all combinations of x for x is 0 to r, for y is 0 to r? Just go ahead and solve it. Is that what you'll do?
Every point will have every point will have how far it is from the center. So it is a n calculations.
Actually, I came up with a shortcut.
So go ahead, Pamela.
Okay, I kind of went along the diagonal thing, but it says integers, and that was a key word. So when we're talking about things that are vertical or horizontal, you know the next integer in is going to be 1 less than r, right?
Mm-hmm.
So for example, let's say r is 5, you can only go 4 out before you bump right into the radius, and that's not a valid point. The next thing I did is, yeah, it was kind of on the diagonal, but I only calculated for a few. And it was basically what I was thinking is where your circle is cutting through, you can kind of determine your outer ranges. So for example, I tried 1 less on the integer on the diagonal and calculated if it was bigger than the radius. And if it was too big, I then went 1 point to the left on the x-axis and calculated that one. And in the case of my equation, that just hit on, but that automatically told me, since this is really symmetrical times 8, if you cut up triangles, that was all I only had to calculate where that thing crossed in 1/8 of the thing to determine where all my valid points would lie. Anything inside of that was okay. Do you understand what I mean?
Yeah, I follow.
Yes, I was actually going to suggest the same thing.
Go ahead. Who's speaking?
Hi, this is Harneet. So, yeah, the person, actually you suggested a very good point. So we don't need to make calculations for the entire circle. We just need to make calculations for 1/8 of it, and then change x to y to get the other half of the quadrant, and then change the negative sign to go to the other second, third, and fourth quadrant. So we just need to make calculations for 1/8 of the circle. And I think the approach we could take is that for 1/8 of the circle, you can start with the center and then keep on adding integer like +1 to x value till you reach the radius. And similarly, like once you increment x, the other time you increment y. That's how you can cover the 1/8 part of the circle, and then just replicate the points till you go out of the, that x square plus y square minus r square when that inequality becomes like greater than less than 0.
I actually was able to do it with fewer calculations, and instead of going from the center in, okay, we look at the sides and we know that the next integer in is 1 less than r. I then went out on the diagonal to 1 less than r, plus the center integer, and I asked that question. If that was too big, I then went to the next integer to the left and asked that question. Once I hit one that was less, I knew I was home free. Do you understand what I mean? So, for example, for my circle, and then of course it's times 8, but for example, on my circle, I had an xy of 1, I had a radius of 5. I knew on the y, I could only go up to 4 plus y, and and then on the x, I could only go 4 plus, and then of course all 4 directions. It's just calculating where that cuts around the corner of that. And so I started there, and then I ended up having to do 2 calculations only to come up with my quote-unquote bounds, because it's integer. So now in the case of mine, I found out that my next one in was on the radius, so I knew it was invalid, but I knew that the one to the left would be less.
Okay, can we walk through this one more time? So you started out with the far right x, right? So you started out at 5, 0, where y is 0, x is 5, correct?
Okay, well, here are my assumptions. So let's say we have a center, an xy center of 1, 1, and I have an r of 5, okay?
Well,
now,
center
I
of 1,
know
1 will
that,
make it more confusing, but go on.
Well, I know it does, but you can move that anywhere.
Yeah.
So what I did is, since it's an integer less than the radius, I know that when I'm going along y, I can only add 1 less than r to hit an integer that's inside the circle. So in other words, I can only go up 4 because 5 would be right on the radius, and you said inside the circle. Same deal with the x. I know I can only go out 4 from my center in the x positive direction, and that's the furthest I can go integer-wise. I then went out to the diagonal, the 45-degree angle from my 1, 1 center, which was 0.55. And that's when I calculated my length. Is it less than r? It was too big. I then went 1 less in the x direction, because I'm working with only 1/8 of the circle, and I calculated if that was less than my r. In my case, it was exactly r. So that I knew that.
Why did you choose to go 1 left as opposed to like
I could have
1 up?
gone 1 down.
Or 1 down.
Because I could have gone 1 down or 1 left. They are actually equivalent because you can dissect your circle. You can dissect this square, which is just 1 of 4 quadrants, all symmetrical. You can dissect it in half. So you're dealing with 1/8 of the problem. And the key is to determine the limits on 1/8, and then you know you're symmetrical all the way around as far as what points are inside and what points are outside. So I ended up only having to calculate length twice to establish. For the top row, I could only I had to be 2 in from that r minus 1, r minus 1. You know, I'm sorry if that doesn't sound quite. I just wish I could draw on your screen, but I can't draw on your screen.
Sorry. So yeah. So anyone with any questions or any follow-up questions?
I think Kavita's answer was simpler, right? You can just do. I mean, anyway, you have to print out almost n square points. So you just have to iterate from x minus r to x plus r and y minus r to y plus r, all the while testing if it satisfies x square plus y square lesser than or equal to r.
Yeah.
And just
I think
produce that.
It's a bad question that way. Let's assume that I want to change the question to say that can you tell me how many points are there, the count, so that way you don't have to iterate through everything. Then Kavita's question would actually be less efficient.
Yes, that's correct.
Right? I mean, I did a bad job of writing the question incorrectly here, so I should be saying that not list out all the points, because by definition that will be an n square ask or like a r square ask. I would rather expect you to just count or tell me the number of points that are there within the circle.
No, actually, if you even have to list the points, then also you just need to solve 1/8 of the problem. You can always just say once you get a point 1, 1. Say
but
you get something.
But Harmeet, the problem is that even with 1/8, right? No. You have to replicate it 8 times, and you will have to basically go through the entire thing. The area of the square is pi r square.
No, when you have determined that point 2, 1 is in the circle, that by default means that minus 2, 1 and minus 2, minus 1, all these points are in the circle.
You can calculate the other 3 quadrants, but still computing the other 3 quadrants will mean that you have spent n square time in that computation. So like
technically 8.
No. 8 you just have to. These are constant time operations. You just have to just change the sign. You just have to make positive thing negative, negative thing positive. So these are constant time operations. You really don't need to iterate again.
So for the first sector, don't you actually have to go through 1/8 the output?
Not even.
Why not?
Because, as I said, I started from the outermost possible and worked in until I found out where the circle crossed. And then you know your offsets. You know how high you can go and how
so
far to the right you can.
If the question were to be count the number of points, then with your algorithm, we just know that we are like 6 points out. So you don't have to iterate over 0, 1, 2, 3, 4, but you can just simply say there are 6 points inside the circle. Unfortunately, the way I worded the question was that I needed you to print out all the points, in which case you will detect that there are 6 points and you would actually have to run an iterative loop to print all of them. So the way the question is worded, both solutions will actually have the same runtime complexity.
Yeah, except of course the calculation is nastier than the printing, but okay.
Yeah. If I change the question to say that count the number of points inside, then I think what you can do is you can actually use a clever algorithm that you talked about. Is there anyone else with a different algorithm or an algorithm that they can articulate without having the need to draw on the screen?
Hi.
Go ahead, Shweta.
You can go ahead. Yeah. So we can measure the distance from each and every point from the center, and if it is more than the radius of the circle, then it's outside the circle. If it's less than the radius, it's inside the circle.
That will be the R-square algorithm that we just talked about, which is less efficient than the algorithm that Pamela was talking. So I was just trying to see if there's a different algorithm that you can use.
Okay.
But good point though.
This is Manoj. I'm just thinking loud here. I haven't tried this out, but maybe we can create a closed form equation for this entire circle for every radius. So we can basically start with one radius and see how many points are there, and two with the radius 2 and how many points are forming within the circle. And this would be definitely a recursive solution, and there would be definitely one formula which would define for every radius this many points are there within the circle. But I don't know what solution, because I have to figure it out.
Intuitively, I'm not convinced that that's going to give you a solution, but who knows? It's possible. Here's like a different here's a different solution, right? Think of this. So if you are able to follow along on my screen, then what I want to do is I want to start from this point, which is essentially far right. Right? Is this inside the circle or outside the circle? Like the far right as in 5, 0, or like x is 5, y is 0.
It's on
is it inside the circle or outside the circle? Like on the border is also considered inside. Is it in or out?
Inside, yeah. In.
If it's in, then you go up.
Are you drawing anything?
No, I'm not drawing. I'm just actually I'm just looking at the image, and I have my mouse cursor on the point, but unfortunately I don't think it shows up. So if it doesn't show up, that's fine.
Yeah.
It does.
Okay.
Now,
so if that,
it's inside.
It's inside, right? If it's inside, then you go up, which is essentially go to 1, 5, which is y 5, 1, which is y is 1 and x is 5. Is it in or out?
Out.
If it's outside, then you go left.
Okay.
Is it in or out? 4, 1. Is it in or out?
In.
If it's in, then go up. 4, 2. Is it in or out?
In.
If it's in, then you go up. This is 4, 3. Is it in or out?
In.
Then I go up. This is 4, 4. In or out?
No, out.
So then I go left. So every time it's in, I go up, which is essentially, I think it's the same algorithm that Pamela was saying, but I think it's just like simpler in terms of explanation.
It's the same, except I went down and left.
Yeah, it's the same thing, and
the fun thing here is that this algorithm actually works regardless of the shape.
Right. So every inflection point, you store the point, and then you get a kind of a basic outline of that, and then you can just do a square area calculation kind of thing and get the number of points.
Correct, something like that. It's very straightforward. You can, as long as you know when you know that x and x plus 1 are out or in, you know that you can just use that value. The one thing here is that this actually works for all shapes that are actually like where the x it has to be monotonically increasing and y should be monotonically decreasing, or the other way around.
So they're symmetrical shapes.
So symmetry is not required in this case. Like you are using the symmetry because you're doing only 1/8. You're doing 1/8 when you're trying to replicate. Let's assume this was not even symmetrical. Then, in order for you to do the first quadrant, as long as it's monotonically increasing in one axis and monotonically decreasing in other axis, you will be able to solve it. It will work. As long as there is no bounce back and it's not like a squiggly wiggly line, this algorithm will work. It works for a triangle, it works for like an ellipse, it will work for any shape where you can deterministically take a point and if I ask you the question, is this point in or out, as long as you can tell me it's in or out quickly, and the function, it has to be monotonically increasing as I go up in y, I want x to be constantly decreasing.
In other words, it can't be convex.
It cannot be concave, I guess.
Yeah, I'm sorry, concave, yes.
Yeah. So that's, it's just a way of looking at it. So this is a stupid interview question. I do not expect anybody to ask this question in an interview ever. And if they ask, I probably would walk out of the interview. But that being said.
You asked
but that being said,
you told us.
It's just fun. It's a problem-solving question more than an interview question. All right?
Yeah.
So if you can go back, I think you can solve, at least for this problem, you can actually have a closed form solution, right? So my hunch, right, is that if you just look at the first, the x-axis from 0 to 5, there are 5 points, right? If you go diagonally up, right, there are 4 points within the circle. And then you go again diagonally up, there are 3 points within the circle. And then you go diagonally up, there are 2 points, right? So it seems to be like, r plus r minus 1 plus r minus 2 plus r minus 3.
It would really depend. It would really depend on your radius.
Yes. Yeah, it will depend on the radius. I'm just kind of thinking where it will break off, right? In this case, if it goes below, the number of points go below 2, it breaks off, right? But you can actually, maybe I can work through some examples, but I think you can actually get a closed form solution for this in a circular situation.
Hi, whoever it was talking, this is Kavita.
Yeah.
I was thinking of the same lines as you are thinking. So in that way, just thinking of it as a mathematical question, I would say that would be 16r plus 1.
16r plus 1? Okay, does that work?
Yeah.
Yep, that is correct actually. That's the closed form.
Yeah.
Yep. That you can calculate, now you can calculate it in constant time.
Yeah, because it's closed form. It's a formula.
Oh, what is that again?
How did you come up with it? Like, is
yeah,
there any...
can someone explain that?
Yeah, theorem or something?
So, yep, go ahead. I think he had.
Go ahead. I think you have a better grasp at it than me. So.
No, the way I did was I basically had I started with the r is equal to 1 and calculated how many points are coming out, and I went r is equal to 2 and how many points are coming out, and then from there it actually forms a closed form. So the first form it is. I figured it was 4, and then it was like based on the formula, it was coming up to some number. So that way,
for the first one, it's 5, right? For r equal to 1, it's 5.
Right, which is if you consider the center of the circle.
Yeah, you have to include the center of the circle. So I'm on the ether part. Right. So if r equals 1, then the answer is 5 points. If r equals 2, what is it?
1 second. Yes, it's coming to 12.
R equals 2 would be these 5, and on top of that it will be 13. The 4, which is the 4 diagonals that you have, the 4 corners. That will be 5 plus 4, 9, and it will be these 4, which will be 9 plus 4 is 13.
Right.
Okay. For R equals 3, what is it? It will fail at some point, because the problem is that the corner, the things that you're actually not including in this case are these points, right? These 2 points, the points which are actually in 1, 3 and 3, 1, 2 and 2, 1 for a radius of 3. No, or something like that. So depending on how you look at it, as the number increases, you'll actually be accounting for more and more. And you can't. I don't think you can have a. Did I hear a formula of like 16R plus 1?
No, actually 16R plus 1 would be only in the case of this radius 5, but we can generalize the number 16 in terms of radius, like maybe R minus 1 square, but we'll have to see if that really works for all the radiuses.
And my hunch tells me that it's not like a, I don't think you can actually get that, because you're trying to, this is a discrete function and you're trying to pretty much map like a continuous function onto it. I don't think there is a good solution like that. If there is one, there probably is like a property that we are not seeing, that I'm not seeing with just like pure intuition. But I can't imagine there being like a solution which is that straightforward for this one. So that's that. So, but anyway, I think it's an interesting discussion. I'm quite amazed at the different solutions that we've come up with. So this is awesome.
This is why we have whiteboard sessions.
Yeah, that's helpful, right? I mean, and you're just thinking through this as you go, and it just works. All right, now comes, this is probably the only coding question that we have today. But it's actually a 5-part question in and of itself. Anyone who's actually read this before? Right, let me walk you through the question in that case. So you're given like a monochrome screen, and a monochrome screen is essentially, it has got like a white or black pixel, that's why it's monochrome. And a 0 represents a black and 1 represents white. And the screen dimension is like it has 320 pixels in the x-axis and 200 pixels in the y-axis. So you could represent it as addressable as 0, 0 is the top left corner, and 319, 199 is the bottom right corner. To save space, you don't want to store the data in as is. So what you're doing is you're like compacting 8 bits in the form of 8 bits, 8 continuous pixels as 1 byte. So each row is actually stored as 40 bytes. Because there are 8 bits in a byte, 40 bytes actually represents 320 bits, and that represents the first row. And you have 200 such 40 byte elements. So in total, the screen is defined as screen of 200 of 40, which essentially, if you look at the image below, it's kind of like a weirdish image, but what the image is representing is that in the first row, 7th bit is set to 1, so which means that that particular byte value would be 128, representing that it's actually there. Does that make sense?
Mm-hmm.
Say that one more time.
The second row, which is like row of 1, not row of 0, but row of 1, has 40 byte array, and the first element of the 40 byte array would be 128, because 128 is in binary represented as, and this is reversed binary because the 0 is on the left and 7 is on the right.
Oh, okay.
Yeah.
Okay, so 120, it will be 128. It's a big endian, little endian notation difference here.
Oh,
right.
Now. Okay.
With significant bit and everything.
Yeah, the least significant bit is to the left and the most significant bit is to the right.
Which is backwards, but okay.
Well, it's backwards. Like what you're thinking is backwards from this perspective. But anyway, I mean, it's the little endian, big endian confusion as always. So yeah, so that's what is given to you. So now what we want you to do is simple step 1 is write a function to clear the entire screen to black. How would you do that? Easy one.
You can just set everything.
And everything with 0.
Just add everything with 0. Yeah.
Can somebody else repeat that? Like, Pamela, wait up. What did you say?
Just set everything to 0.
That is little different from what Pamela said. I heard once someone say and everything to 0, and I heard someone set everything to 0. Are they the same? Are they different?
Yeah, so this is Arneet. Actually, we all are saying the same thing. So we need to set the values to 0, and to do that, you will AND the current values with 0.
Why do you need to AND the current value? Why can't you just assign the value to 0? I'm just curious.
Yeah, that's the same thing.
The same thing.
They practically will result in the same thing, and there's no time complexity there. But I'm just curious to see why would you choose ANDing it to 0 versus setting it to 0?
No advantage.
Setting will have a damage, but ANDing will not have any damage.
No, probably it depends if we are looking at that level, then whether AND operation takes less time, or just the assignment takes less time.
What do you do after the AND? You have to assign it.
You have to store it in the memory.
Even if you AND it, you still have to store it. So I don't see any point in ANDing it.
Yeah.
Hi, this is Raja. Is it because you're ANDing a byte, so you're doing like 8 at a time?
No. Even moving to memory doesn't happen at byte at a time. Like, it depends on the architecture.
So I like the discussion. Okay, so here's what it is. So Shweta, you mentioned you brought up some point around one is destructive and the other one is not. I mean, they both are destructive. At the end of the day, you want the entire array, the 200 times 40 bytes, the 8,000 byte array. All the bytes have to be set to 0. That's what you want, right?
Yes.
If you're cleaning the screen to black, you are setting everything to 0, and there is no other way to dice it. You have to set all the 8,000 values to 0. Now, the only argument that I see for setting something to 0 versus ANDing something to 0, the reason why you want to AND it to 0 is what you're actually trying to say is like, what you're depicting is the act of actually like overlaying a black image. And the way you overlay a black image on anything is like if you have instead of like you don't want to do everything, but you want to do only partials, you will be using an AND function. So, but using an AND function will not cost you extra, but it's just different. So in this case, potentially, you may be actually able to do like a big memcopy operation of the entire array to 0, double dimension wise, and call it done. Okay. So and is it works, but it's fine.
Yeah.
The next one is actually how would you clear the screen all white?
Just set everything to 0, then flip all the entire two-dimensional array by taking byte by byte. Just flip it using a NOT operator.
Yeah, just OR it with 1 1 1 1 1. That's like all ones. So.
Or XOR?
255.
No. You have to OR it. You want to make sure that it's 1.
You can just assign it.
So it will be all zeros, right? So.
No, don't take the first, like, I'm not sure if it is like after the first thing.
Okay.
Yeah.
Yeah, then you can OR in that case.
So again, the same conversation. Do you want to OR it with 255 or do you want to set it to 255? And both will work, but it's just a conceptual thing, all right? You do not want to use any other operation. No XOR, and I think it was Sri who mentioned this. Set it to black, and then you set it to NOT. I mean, don't do it in 2 steps.
Yeah.
All right? Bad idea. Okay?
I just want to know why you came up with AND and OR in this case. So just setting is enough, right? Is it something related to something else? Some other concept?
No, setting is
AND and OR?
Setting is enough. Who's speaking?
Why the concept came up with, this is Karthik here. Why the concept came up with AND and OR? That's, I'm a bit confused. Because setting is enough, right? Why are we complicating?
Anybody wants to answer that? Harneet?
So we are not really complicating it. It's just that since they are using, like what I was thinking was, since they're using 1 bit per pixel, so I'm thinking at that level, okay, so that we don't miss it. So I was just thinking in bitwise.
Even in bitwise, you just set to value, right?
Yeah, so you will have to calculate the value, which you might, calculate wrong. So just OR it with 111, which is like a thing or something like that. Completely the way I was thinking.
Yeah, that's 2 steps. Again, it's a override on the processor, like AND or OR is one operation, then equals is another operation assignment. So the number of CPU cycles are more in this case.
And you're also retrieving the data for your ANDing or ORing operations, right? You have to retrieve the data and you're discarding it completely anyways. So, I mean, yes. So let's move on from this, but you're right. Setting assignment will be the best way to do it, and there are probably other smarter things you can do with just assignment. The OR and AND actually are helpful for a couple of other activities, so we'll leave that for now, and then we'll come back to it. All right?
I'm not pretty sure though, but at the processor level, I think they have made the basic bitwise operations very efficient. So
yes,
doing those operations and then assigning to them.
What is the objective? After you finish your bitwise operation, what are you doing? You're setting it back in memory, right? Assignment.
Yeah.
So if I were to say A equals 0, and if I were to say A equals A and 0, I cannot imagine A equals A and 0 to be faster than A equals 0 ever.
I completely agree with you.
So that is the confusion that people would have when you're trying to do that. And in an interview, I would ask you the same question that Karthik just asked. I would ask the same question, which is, why are you confusing it? And I think the give up answer there is like, yeah, I should have just set it to 0. It's just that the problem is that you are assuming it's a 8-bit mask right now. So setting it all to 1 is 255. But what if it is like a bit mask which is representing 255, or like 10 bits or 16 bits or 20 bits or something? Then I just need a bit mask which is just easier rather than like having a mathematical magic number. I don't want to be setting it to 1023. I would rather have like a binary definition of what that number is and then use it. But in any case, I would still go ahead with assignments, but I'd have constants defined to know what to set it to white.
I just have one more point to add. Like you said about A equal to A and 0. The compilers these days are smart. They might just optimize that to set it to 0. But this is the point.
Yeah, fair enough. That is right. I mean, all I'm saying is I cannot imagine a scenario where A equals A and 0 to be faster than A equals 0 ever. I mean, I assume compiler will equalize them both. Okay. But I can't imagine the AND operation to be faster than the plain assignment. All right. So moving on to the third question. So this one's like I want to draw a vertical line at a given x and a given y1 and y2. Any takers?
I'll bite if nobody else will, but I'm going to describe an approach.
Go on.
Go on? Okay. Number 1, you go down to the row that corresponds. Okay. Now, one of the things that I keep getting messed up with here is 0, 0 the lower left-hand corner or the top right-hand corner or what?
On the screen, it's top left.
Top left. Okay. And so
it's Y1
right would be... I didn't see it.
The image. I've got 0, 1, 2, 3, 4 on left written on the image.
Okay.
And I've got 1 through, I don't know, 45, 46, 47.
I never saw the image.
Aha. Huh? I added that I think yesterday.
Okay. Okay. And so does y increase as it goes down?
Yep.
Okay, then I'm cool. And then x increases as you go right, correct? Yeah.
Yes.
Okay, I defined a bunch. Number one, what you've got to do is, and that means that y1, okay, so basically first you look up the row that corresponds to your y1, which is y1 minus a 1, since you're counting at 0. And then you got to figure out which byte in the row you're going to be dealing with. And I would think that would be x divided by 8, integer division, right? Because there's 8 bits per, and then you've got to figure out which bit inside that byte you're dealing with, which is the results of the mod, what's left over. Then I had 8 constants defined with a bit, and you OR that constant with that particular byte. You OR because you don't want to overdraw anything else. And then you keep going down each row, except once you've calculated which byte in each row and which bit, you're home free with after the first time. And then you stop when you've hit the y2 coordinate. Does that make sense?
Anybody else with a question or a concern about this approach?
I did not understand this.
Oh, okay. So I'm not sure if I completely understood this, but are you saying what I was thinking was we are given the value x, right? So let's assume that y1 is less than y2. We just need to keep on incrementing y1 till we reach y2, and then we need to set the corresponding value in the screen data structure. That's it, right?
Right, but what you're given is like you would be given something like x is 7, right? If x is 7 and y1 is 1 and y2 is 3, then you only need to set that bit alone, not the entire value.
Okay.
And what I heard Pamela say is that given that x divided by 8 is 0 because x is 7, you know that you need to tweak or twiddle with the first column in the array. So you will actually be twiddling 1, 0, 2, 0, 3, 0, and 4, 0. That's what you're twiddling. And how will you twiddle with it is that you need to actually apply a what mask? Is that an AND mask or an OR mask, Pamela?
OR.
Because you're drawing a line white, so you will have an
yes.
OR mask, and the OR mask will actually contain 0, 0, 0, 0, 0, 0, 1, whatever that equivalent of. And in this case, since it's flipped, it will be 128 is the value that you're having. If
see, that's where I get thrown off is the orientation.
It's okay. It's sort of on purpose. Yes, Kavita, go ahead.
Can you show it in the Etherpad?
No, I couldn't understand what you're saying. Can you repeat that?
Can you show it in the Etherpad, what you're saying? Because I'm not able to comprehend it.
In the Etherpad, sure, of course.
So is this a
Etherpad?
This is
so what you're
64-bit
actually trying to do is, so you want to set the screen, this is screen of y of, this is xb, which is the x byte. Okay, so you say xb equal, I'm on line 22 on Etherpad. xb is actually equals x divided by 8, okay, and the x reminder is actually x mod 8, okay. If xr is equals 0, then your bit mask is actually, the first bit is set, all the 7 bits are 0, which is in the big endian, little endian notation is actually just 1. If xr equals 1, then bit mask should be 0, 1, 0, 0, 0, 0, 0, which is actually, and so on. So actually it is, in this case, it's actually simpler because it's not because it's inverted. Any concerns?
So you're talking about shifting it.
Yeah, bit shifted, right? You don't have to create masks. You just create the mask dynamically. You don't have to have 8 constants, as you said. And Pamela, you missed this one, and I think Harneet got it. Was you're assuming that y1 is less than y2, which is not always the case. So you'll have to. I know it's trivial, but we have to in interviews we got to be super attention to detail is important, and I know certain stupid interviewers would take that and say, someone's making assumptions.
Okay.
Without stating them. So just FYI. So it's I mean, you have a concept.
You got to find the y that's the greatest, yeah.
Yeah. So basically, you would say if y1 is greater than y2, then you would actually say t equals y1, y1 equals y2, 2 equals t, or something like that. Or some crap like that. You'll have to do that first. So screen of y of xb and r, right? And that's it. That's all.
Mm-hmm.
As simple as it can be. Does that make sense, Kavita?
Yes. So basically right shifting by 1 bit. So
you're super feeble, so I can't hear you. You have to reposition your mic. Sorry.
Oh, sorry. So basically right shifting by 1 bit.
Not 1 bit, by as many bits as necessary, right? If the remainder is 1, then I shift it by 1, which is essentially the second bit. If it's 0, then I right shift by 0. So.
I have a question.
Yeah, go ahead, Manoj.
So it's Arun actually. So
Arun, hi Arun.
Yeah. So you're saying that the LSB is at the rightmost, so from what I understand, these cells, individual cells, are they bits or bytes?
Each individual cell here are bits.
Bits.
And the LSB is actually to the left.
I was going to say the LSB is to the left, right?
But
yes.
The endianness is concerned with different bytes, right? It's not concerned with different bits. So that's why I was confused. I thought it's 8 bytes with a 64-bit architecture or something.
Oh, sure. I understand. Sorry, I should not have used the endian as that thing. It's the same concept, but essentially it's just saying that depending on how you store how you represent or depict your bits, you could actually call the left bit as the least significant or the right bit as the least significant. So in this case, the leftmost bit is the least significant, which throws people off because normally you are used to the left being the most significant. So I apologize. I shouldn't have used the term endian in this case. And and it's just that all you're saying is the bits are the leftmost bit is the least significant, and the rightmost is most significant in this case.
I see. Okay. Thank you.
Yeah, thanks, Aaron. Kavita, is that so far so good?
Yes. Yes.
Fantastic. Now moving on to the next question, which is the fun one. Given x1 and x2 and y, draw a horizontal line. This is actually straight off of Gail's book, if I remember correctly.
Yeah.
What, no takers?
So what is write a function to draw a horizontal line in white and in black? So it should be alternating 1 and 0s?
No. There are two different questions. It's like how would you write if you want to draw the line in white, then what's the answer? And if you want to draw it in black, what's the answer? There are two different questions. It's like 4A and 4B.
Oh, okay. So isn't it the same opposite as the third one?
No, it's a bit different.
A lot different actually, because the third one is vertical, right? So you create one mask and you can just replicate the mask across the y-axis.
Mm-hmm.
But for the fourth one, you can't just get away with one mask.
You're going to have to determine, well, number one, you're at least on one row. That's simple. And then you're going to have to determine which bytes are involved, and then the zone of bits within each byte that's involved.
So basically,
and I would imagine
there are two scenarios here. Please go ahead.
Go ahead. Somebody was saying.
Yeah, just I thought like so as the y is fixed, so the x1 and x2 can be in the same bit and can be in a different bit. There are two scenarios. So if they are in the same bit, then I can go to that particular bit, and I can create a mask and go to that particular index and flip it. If they are different, which means they are in the different bits. Can be in the, it's like can be in the, for example, x1 and x2 is 7 and 17. Then they are in, one is in the 0th index and the other in the 2nd index. So in this case, whatever is in between, the whole thing we have to flip, and the other boundary conditions are like, we need to find like from x1 to its.
Karthik, you're being a little too. We are barely able to hear you. Can you reposition the mic or speak a little louder, please?
Is it audible now?
Yeah, a little better. Go ahead.
So there are two scenarios here. One is x1 and x2 can be in the same bit, which means the same index of bit array, or they can be in a two different indexes. So let me take both of them in the same index. Like if it's x1 and x2 is 10 and 14, they are in the same. They're in the first index of the bit array, right? So in this case, we will create a mask between those two elements, those 2 points, and we will apply for that particular horizontal line for that particular y. Okay. So if it's if they are in a two different index positions, like if it is, for example, x1 is 6 and x2 is 17, then there are 3 index positions involved there. One is 0 and 0, 1, and 2. So the one index will be completely flipped. The whole bit in this particular index 1 will be completely flipped, whether with white or black, or the other two, 0 and 2. So at the position x1 to its boundary of that bit, like if x1 is 5, so 5 to 7 it has to flip, and if x2 is 18, 16 to 18 it has to be flipped. So we have to create the marks accordingly and flip it. So does it make sense?
Anybody with a question or a concern? Did people understand what he's saying?
The one optimization is, I think I'm just extending on what the previous person was saying. Like he already mentioned that we can, based on x2 and x1, we can calculate how many whole chunks of bytes are covered, and then like create an all one mask, and then just OR it. So that's one optimization which I'm seeing.
So Sri, why would you want to create an all one mask and OR it? Why would you not simply set it to 255? I'm going back to the same question that we had for Q2.
Yeah, right. Correct.
Okay.
Yeah.
Fine. So let's say you did that.
Yeah.
What do you do? What is the other part?
then we have to calculate the mask for the other byte chunks, which is not completely covered. Between x1 and x2. And then we have to update those separately.
How will you do that? The x1 and x2. How will you create those masks?
So we have to find out the starting bit position.
It's going to be just ORing all of the bits that need to be turned on.
How do you detect what bits need to be turned on? Will you keep 8 variables like before, or can you mathematically arrive at that?
Can you use modulo 8?
How will you use modulo 8?
That would just show you one bit, not all of them.
Yep, and that's also not right? It'll just give you a number. It'll give you a number between 0 to 7. That's not even one bit. It could be anything. So the way you deal with this is that you want to look at if x1 r, which is a reminder. Okay, I'm on line 54. If x1 reminder is 7, then you want the value to be 128. If x1 reminder is 6, then you want the value to be essentially 128 plus 64, right? And so on. If x1 reminder is 0, then you want it to be 255. Is that not it?
Can you
okay, yeah, with the plus, yeah.
128 plus 64?
These are the bits, right? 7th bit, 6th bit, 5th bit.
Yeah, the pluses do it.
Right? It's setting that appropriate bit is what I'm trying to get to, but you should be able to do it. So these are like the 8 constants you can keep, but you can actually mathematically arrive at this as well. And how would you do that?
So we have the remainder, right? So from the remainder, remainder is 5. From 5 to 7, we add the values like 2 to the power 5, 2 to the power 6, and 2 to the power 7, and we will get the mask for that particular bit. That is for x1. And for x2 similarly, we will find the mask and in between x1 and x2, so there can be the whole bit has to be flipped. Those you have to flip, assign with 255.
So I don't know if you're seeing the thing I wrote. It's actually 255 left shift x1r. That's it. Is it not? Because for 0, nothing gets shifted. For 1, everything is 1 except the rightmost one.
Yeah. This is for the lower x, right? Like the leftmost x.
Yeah. This is the lower one. For the right one,
I would have to do a right shift.
For the right one, essentially what you want is for x2r, if x2r is 7, then you want it to be 255. For x2r is 6, right? You want it to be 128 or 127. x2r is 0, it should be 0. No, it should be 1. Right? Something like that? Six to 6, will that work?
I'm thinking.
Yeah, this will work for the yes.
Okay. The fun little thing is that if x1 and the bytes are the same, then the way you get the combination is actually you just have to AND these two, and that gets you the combo mix. Single AND, not double AND. Sorry.
Right. If it is
right.
in the same cell. Right.
Yeah. If it is in the same cell, then the ampersand will actually get you this information. Right? So that's all we had for the programmed content for today. I'm going to turn off the recording at this point, and then